Good evening, everyone. Welcome to our next webinar in our Learn at Home series, which is brought to you by the University of Rhode Island College of the Environment and Life Sciences, and more specifically, Cooperative Extension. This webinar is titled Property Value Impacts of Commercial Scale Solar Energy in Massachusetts and Rhode Island. And we are very lucky to have Dr. Corey Lang here, who's an associate professor in the URI Department of Environmental and Natural Resource Economics. Next slide. So just for those of you who may not be familiar yet with cooperative extension, I like to take this opportunity to draw your attention to the fact that we do have a small but mighty cooperative extension unit at the University of Rhode Island, and we focus our efforts on 5 what we call strategic areas of focus. And obviously this webinar falls within the energy efficiency, conservation, and renewables area, but we have programs that touch land stewardship, food systems and agriculture, water resources, healthy lifestyles, and energy. So we're bringing science-based resources of the institution out to you to help you solve problems, and this webinar is a great example of that. Next slide. Thanks. And as we move through this time, it's really important to us and for us to draw your attention to the fact that we want to make sure this information is available to everyone. In the age of online program delivery, it becomes a little bit easier because folks don't have to come to us to get information. So we already had a question about how to view these webinars after the fact if folks miss them. And the answer there is that they are all uploaded to our URI Cooperative Extension YouTube channel. You can easily find that by typing URI Cooperative Extension into the YouTube search engine. And so again, I draw your attention to these guiding principles and appreciate you helping us spread the word on this information. Next slide. So before I hand it over to Dr. Lang, I just want to point a few things out. The first is that you will get an email immediately following this webinar. I think it'll come from a messenger at WebEx email address. And in that email, there's a brief survey that we really appreciate you filling out. We actually read the results and we use the results and the data that we're able to collect to improve these sessions. So I'm one of the people that looks at them, so thank you in advance for filling them out. I hope I get as many completed surveys as there are people here tonight. The other thing is that if you navigate to the bottom of the screen, there are 3 dots, and if you click on that, it'll bring up the Q&A box, which will ask you to use when you have, if and when you have questions for Dr. Lang. We will answer all of as many of those questions as we can at the end of his presentation. And so find your way to that Q&A as soon as you can. And lastly, like I said, this webinar and others will be uploaded with closed captioning to our YouTube channel. So without further ado, I will be back at the end after Corey presents, but I'd like to welcome Dr. Corey Lang.
Hi, thank you, Kate, and thank you all for being here tonight. Very excited to present this new research, receive feedback, and talk to you all, right? Part of this project is about engaging with stakeholders. And so I'm really excited to share these results, and instead of just an academic article that sits on a shelf somewhere. So the plan for tonight, I'm going to give some brief motivation for why we're doing what we're doing. I'm going to talk about the methodology we use to analyze property values in response to solar arrays and try and build up some intuition. Even though it's heavy in the statistics, we'll try and build up some intuition for what we're doing. I'll present results for the solar array analysis, and these will be basic results as well as some important heterogeneity. So we explore different factors that affect results that are pretty important for interpretation. And then I'll conclude. So starting in 2012, commercial scale solar arrays were developed in Rhode Island. And there weren't very many early on, but since 2018, the pace has really increased. So this is an important issue, and the governor has set ambitious goals for renewable energy, and that clearly has had an effect. So, we need to be aware of what other impacts or what ancillary effects this policy goal has. It's become a contentious issue. While I think everyone is aware, or most everyone is aware and behind the idea of carbon mitigation and realizing the need to switch to renewable energy sources, there are some possible costs associated with solar development because of the land use change implied. Solar energy, when it's not on non-residential solar energy, takes up land, usually. There are some cases when it doesn't, but often it does. And so we think about this as a land use change dynamic, and there are some costs associated with that. So because of those costs, it's really created a contentious debate. And sometimes there are environmentalists on both sides of this debate, and it's fascinating. And we need better information, right? We need to, there's a lot of calls for better decision making. And so this debate prompted me to write a grant in 2018 to use economic research to assess the costs associated with solar and ways to minimize them. This grant was funded by the USDA, and I acknowledge their support for this research. So there are many concerns related to solar development. One common concern is residential property values. And nearby residents have concern about losses in equity and wealth, right? Houses are, for the vast majority of people, if they own a house, that is their largest asset. If that changes in value, that can be a big deal. And so, of course, there's going to be concern when there's this new land use type. What effect does this have on my house, my equity? Okay, so that's a concern that people have. Also, property values act as an indicator of preferences for a given location. When people are shopping for houses, they make trade-offs, right? About there are bedrooms and bathrooms, all these characteristics, but also locational amenities and disamenities. And they're thinking about all these factors. And so if people are not keen to live near a solar array, that's going to be reflected in prices. And so by studying prices, we can understand people's preferences for living in proximity to a solar array. While examining property values is common in economics, there's no existing academic research on property value impact of commercial scale solar. And so what we're presenting here, what we've developed over the past year or so, this is really the first paper on the property value impacts of solar, which is exciting. So let's get into a little bit more about the methods. As I said, this is using property values to estimate preferences, is a frequently used method in economics to place a value on localized environmental amenities and disamenities. This method has been applied to things such as power plants, brownfields, Superfund sites, lead exposure, and many other topics. As I said, this very common method, and it's been applied, there must be thousands of papers that have used property value models to assess preferences. What's nice, I think, for you all stakeholders, these results make sense, right? It makes sense that people buy houses and they want to live in certain areas and they don't want to live in certain other areas, and the prices reflect that. And so when we study an environmental disamenity or amenity, one, the results are intuitive, but also the results are policy relevant. So here's an example of a paper published in 2017 by Hanninger et al. They analyzed federal brownfield remediation. what they found was that property values nearby a remediated site, those values increased 5 to 11% following the remediation, right? From before to after, they went up 5 to 11%. And so first off, we can say, well, that makes a lot of sense because there are all sorts of environmental concerns and hazards associated with brownfields. And so cleaning them up is going to increase values because it makes that location more desirable. But also it's policy relevant because the calculations that Hanninger et al. Did showed that the aggregate benefits of those cleanups measured through the property market exceeded costs, right? So they knew how much it cost to clean up a brownfield, and then they could look at all the houses impacted and all those benefits and do a benefit cost calculation that said, yes, this is worth it. The federal program is paying off. Okay, so a little bit more about the method. You know, maybe you guys are getting it. That's awesome. But I just want to show you some results that are indicative of the types of results you get from these property value models. So I just took some data from Narragansett, coastal town, and I examined how prices vary with respect to proximity to the ocean, housing characteristics, as well as some time variables to control for price fluctuations. Okay. So the natural log of sales price is the dependent variable. And that's a common transformation that happens for this type of data, but it means that the interpretation of model coefficients is in percent. This will all become much more clear when I get to the next slide, all right? So here is some regression output. This is the results of the mathematical model. And we got all these numbers, but we can make sense of them, okay? So let's look at this key variable of if a house is within a quarter mile of the coast, the coefficient is 0.212. We interpret that, again, in percentage terms. And so houses within a quarter mile of the coast are worth 21% more than those not within a quarter mile of the coast, all else equal. Okay, that's how we interpret that 0.212. The number under that, the 0.014, is a standard error. That gives us a sense of how confident, how precise we are in that estimate of 212. And what we can do with the standard error is form a confidence interval. And so we can say with 90% confidence, the premium of living within a quarter mile of the coast is between 18.9 and 23.5%. So 21.2 is a point estimate. It's it's what our best guess is of what the true premium is, but there's some uncertainty. And so we can bound that uncertainty through a confidence interval. Moving on, we have lot size and lot size squared in the model. So obviously lot size is important. You're going to pay more the bigger the lot. But what we see is a positive coefficient on lot size and a negative coefficient on lot size squared. That indicates, right, a parabola, an upside down U shape, which tells us that houses with larger lots are worth more than those with smaller lots, but the price increase diminishes with size, right? Going from a 0.25 acre lot to a 0.5 acre lot is going to lead to a much bigger price increase than going from a 1 to a 1.25 acre lot. Last one I'll interpret is central AC. And the coefficient 0.082, that's 8.2%. So houses with central AC are worth 8.2% more than houses without, all else equal. Okay. Now these results have nothing to do with solar, but it's just to give you a sense of what these property value models look like. They give intuitive results, but the magnitudes can be really meaningful. Now let's get back to solar. So we designed a model to examine how house prices change when solar arrays are constructed. The null hypothesis is that solar arrays have no impact on property values, and the alternative hypothesis is that solar arrays have a negative impact on property values. We developed a mathematical model, a regression model, that analyzes how house prices vary with periods, pre-construction, post-construction. So we're comparing the prices before to after, as well as distance. And we're going to separate how far a house is, the distance from the solar site, from 0 to 1 mile, and we'll consider that the treatment group. And then further away, 1 to 3 miles, will be the control group. So we'll be comparing how these properties that are within a mile of a site change relative to those that are further away. We're also going to examine heterogeneity, as I alluded to before. And so we're going to look at some additional, try and tease out some heterogeneity in distance by splitting up that 0 to 1 mile treatment group by looking at very close and versus a little further away. Prior land use is a big issue here in solar siting. Often, solar arrays are sited on forested lands or maybe farmlands, but they can also be sited on brownfields, covered landfills, parking lot canopies. And so we're going to measure what the land use was before solar and include that in the model to test for heterogeneity by that prior land use. And then we'll also take into account surrounding development and proxy this by population density of a town. Thinking that maybe there's a divide in the effects between rural areas and non-rural areas. Our model will also control for housing unit characteristics. Obviously, things like bedrooms and bathrooms influence the price of a house, and so we need to control for that. So that'll also be in the model. Now, the models I present tonight will be repeat sales models. And what this means is the observations in the sample, the transactions in the sample, are only properties that sell both before and after construction. This is a really powerful model because you're comparing the same property in both time periods, as opposed to property A in the first time period and property B in the second time period. These repeat sales models are very powerful for capturing things that the researcher cannot observe. Okay, so we feel really good about the data we have and these models we're able to apply. We'll also be controlling for price trends by county. This is just to allow for price fluctuations of the market, but we allow these price fluctuations to be different by county. All right, so let's get into how we built the data. Essentially, there are 3 components to our data set. There are the solar arrays, the housing transactions, and the prior land use. And that all gets combined into our consolidated data set. So here we have a map of all of the solar arrays in Massachusetts and Rhode Island as of that are online, that are feeding the grid as of August 2019. We included Massachusetts, right? So we're at URI, and it'd be nice to be a little Rhode Island centric to get results that are specific to our state. We needed to include Massachusetts because of all of the solar arrays Massachusetts has. It just gives us so much more data. It's a really key component to the analysis. As you can see in this graph, Massachusetts has much more solar than Rhode Island, and they started developing sooner, right? So they were ahead of the curve relative to Rhode Island. In all, we have data on 284 installations of size 1 megawatt or greater. That's greater than 1 megawatt is what we'll consider commercial scale. These 284 installations have 874 megawatts of capacity, and the data source here was the EIA. One thing to note is that, particularly you can see this in Massachusetts, but these solar arrays are spread throughout the state. It's not just one area, which might be a concern if we're studying property markets and maybe one area is different than others, but these are fairly uniformly spread throughout the state. Housing transactions. So we use we get housing transactions from Zillow Ztrax data, which is a proprietary resource, but available for free to researchers. And we have a tremendous number of transactions. We observe over 419,000 transactions within 3 miles of a solar site. And this is for the years 2005 to 2019. This graph gives you a sense of the distribution of how far these houses are from the site. And all we're doing here is drawing concentric rings around a solar array. And so, of course, as for those small distances, the rings are pretty small. And so there's just less area for houses to exist. And so we don't have as many transactions, 0 to 0.25, as we do for further distances. That being said, we still have a tremendous number of transactions. It looks like we have around 4,000 transactions within a quarter mile. That's a huge number, right? There are other studies, like I said, there's no other studies of solar, but there are a lot of studies of wind turbines. And the vast majority do not have this much data close to the energy source, right? In that case, close to a turbine, in this case, close to a solar array. And so we feel really good about the amount of data we have and the amount of data that's in close proximity to solar arrays. If an effect is there, we think we are confident that we'll be able to pick it up. Another thing I want to mention is, I'm aware that there are, appraisal studies of how property values respond. And I've seen some of these appraisal studies, not all of them, but some of them, and often they include, it's a comparison of just a few properties, a handful of properties. And the concern I have is that there are a lot of idiosyncratic factors to how property values change over time. And so I don't have as much confidence in those when you're just picking a handful of properties versus having 400,000. And so those idiosyncratic factors tend to wash out as noise, and you are able to pick up a stronger signal when using this much data. So prior land use, how we constructed this variable was this was all done in GIS, ArcGIS, and started with the base layer, which was just latitude and longitude points of solar array centroids. Then we approximated the footprint of solar arrays using a conversion that 1 megawatt is about 5 acres. And because we don't have the exact footprint, we just use circles centered on the lat long. Then we looked at land use land cover data for Mass and Rhode Island and determined what was the predominant land use in that circle at that time. And using years 2005 for Mass and 2011 in Rhode Island, these predate any solar development. And so we're getting what is there before solar goes in. With that, we categorize all sites, all solar sites, as either greenfield, which is farm or forest land, or not greenfield, which is going to be everything else, but industrial, commercial, brownfields, covered landfill, etc. And so with all this work, we have greenfield versus not greenfield in terms of classifying prior land use. Okay, drum roll. So these are the main results, the first results I'll present. And there's a lot of stuff going on in this table that tells you, it's just for completeness and for science sake. This is the repeat sales model. So we have 230,000 transactions that are in the repeat sales. The 420,000 is when we're not using repeat sales. I'm not displaying those tonight. Those are in the full report, which hopefully will be posted online tomorrow. Okay. So we see this one coefficient, And there are other coefficients in the model, right? There are lots and lots of variables, but this is the coefficient we care about. And it's a minus 0.017. The standard error below it is small relative to the size of the coefficient. And so we have a fair bit of confidence in the preciseness of this coefficient. How do we interpret that? Well, again, this is percentage. And so that's interpreted as a minus 1.7% change in property values after construction. And I have that written out here for more clarity. So on average, housing values decline 1.7% after construction for those properties within 1 mile of the solar array, relative to properties 1 to 3 miles away. Right? So this is a relative change for the treatment group to the control group from before to after construction. 1.7%. Now, 1.7% seems like a small number, but when you think about how much a house is worth, which in our data set is about, and I forget the exact number, but about 330,000, I want to say, brought to 2019 dollars. That 1.7% represents a loss in value of $5,751 on average. And I want to emphasize the average part. It's not that every house within a mile loses 1.7% of its value. This is average. Some might be more, some might be less. This is an average, okay? How else can we interpret this number? Well, remember, we use property value models to understand preferences. And so what we can say is that on average, people are willing to pay $279 per year to avoid residential proximity to a solar array. We got to the 279 through the 5751 and thinking about what annual payment in perpetuity equals 5750. Okay. So that is a reflection of average preferences of home buyers. They're willing to pay $280 per year to buy a comparable house that is further away from that solar. We talked about confidence intervals before. So the 1.7% is our point estimate. It's what we think is the best guess for what the true effect is. But there's imprecision, right? And so our 90% confidence interval goes from minus 2.7% to minus 0.7%. Anything in that range would be consistent with the data. Anything outside that range would be inconsistent with the data. Again, with 90% confidence. Okay, hopefully you all are still with me. Now I want to get into heterogeneity. All right, we talked about these important factors of heterogeneity. The first one we'll explore is distance. So before, we were treating everything within 1 mile as treated and everything outside, everything 1 to 3 miles as control. Now we're going to split it up, and all of these are coefficients. All of these are treatment effects relative to 2 to 3 miles. And we'll go coefficient by coefficient to understand what this is saying. So our coefficient 1 to 2 miles says that there's really no change for properties 1 to 2 miles compared to those 2 to 3 miles. And this is what we expect. We thought that those properties more than 1 mile were unaffected. And so this makes sense. This is what we want to see. Properties that are 0.5 to 1 mile and 0.1 to 0.5 miles, here we see a 1.7 to 1.9% decline. This is consistent with the overall average treatment effect that we saw before, just about the same. Okay. Where we see a big difference is those properties that are very close. Those properties within 0.1 miles, we estimate to decline 7% in value. Now, this is not as precisely estimated as our other results. There just aren't that many properties within 0.1 mile, right? So our confidence interval is quite large. Our confidence interval ranges from minus 13.2% to minus 0.7, right? So a very big confidence interval. The results certainly suggest that there are larger impacts for those properties very close, but there's a fairly wide confidence interval that is consistent with the data. Okay, more heterogeneity. Let's think about prior land use first. This top model, what this is saying is that, you know, this term here, which is for greenfield sites relative to non-greenfield, it's negative, but small, and it's statistically insignificant. So it's suggestive that greenfield developments lead to larger negative impacts, but it's not a very strong result. It's only suggestive. We can't nail down. We don't have enough precision to really have a lot of confidence in that result. Here, by population density, so we've split our sample and classified towns and properties that are within certain towns as either rural or not rural. And the reason I'm using not rural as instead of say urban is because there aren't that many solar developments in urban areas. And so it's more rural versus suburban. There's a little bit of urban in there, but mostly rural versus suburban. Okay. And what these results suggest is that those non-rural areas, those properties experience minus 2.4% change in property values. But the rural areas, we see a positive coefficient here. And what we need to do is add these together to get the impact for properties in rural areas. And so you can see those are going to wash out. And so rural areas, we're finding those property values are not being impacted by solar development. Okay, that really the effects are concentrated in suburban areas. Okay, next slide. And now we're getting even more complicated. Why not? We're looking at the interaction between greenfield and rural. And so we have a lot of coefficients here. We're splitting it out into, non-greenfield and non-rural areas, greenfields and non-rural, non-greenfield and rural areas. Anyway, it's a 2x2 type of design. And let's go through what these coefficients mean. For non-greenfield sites, we're seeing that the effect is fairly similar in rural and not rural areas. It's small negative effects, but imprecisely estimated. Okay, so it's suggestive that there's a negative effect, but we don't have a lot of statistical confidence in what that effect is, or the sign of that effect. Okay. However, when we look at greenfield developments in non-rural areas, we see large negative impacts. So for greenfield sites in non-rural areas, we're estimating a negative 5% change in property values, a 5% decrease. And how I get to that 5% is summing these two coefficients. So minus 5%, that's really big. We'll talk about why that might be in a second. Let me finish up the last coefficient. So now if we look at greenfield sites in rural areas, what we're doing is actually adding up all of these coefficients to get that effect. And when we add up all the coefficients, we get a positive 0.8%. And this is statistically insignificant. So we could think of this as a 0. But what these results are saying is that these greenfield sites in rural areas are not leading to price decreases in nearby housing values. Okay. So now let's think through this interpretation. Let's try and make sense and tell the story. So first up, with the distance, what we see is that houses very close could experience large declines in value. As I said before, we don't have a ton of confidence in it because there are large standard errors, but the results are quite suggestive that there could be big negatives for those very close properties. Then in terms of the greenfield and rural, non-rural, what we find is that houses near solar developments built on farm and forest land, where those land uses are scarce, right? So in suburban areas where there's lots of, there's more development than in rural areas. And by development, I'm not talking about solar, I'm talking about houses, commercial areas, that kind of, just the land is more built up. And so farms and forests are more scarce. When those properties are developed into solar, we see larger declines in value relative to places where those land uses are abundant, right? So in the western part of Rhode Island, where there's abundant forests, and what the results suggest is that we're not seeing property values decline when near solar in those types of areas where that type of land use is abundant. Okay? So I think it's a scarcity story of how, just how likely, how valuable is that nearby farm and forest based on what else is around. Moving on, hopefully going to end up in soon, so we have some time for questions. Okay, so those were the results, and we made sense of them and told a story about them. Now we want to think a little bit bigger and think about this. Think about a policy that is increasing solar development in Massachusetts and Rhode Island. And think about the accounting, think about the benefits and costs, okay? So there are market benefits, and who's involved in the decision are developers, landowners, and municipalities. And all these groups benefit financially, right? They profit. And all of these groups are involved in the decision. Then there are people outside of the decision. And in economics, when people are outside of the decision but impacted by the decision, we call this externalities. There are two big externalities that are occurring here. One is that carbon emissions decline, right? We all benefit from reduced carbon emissions. And in my opinion, we need to be shifting to renewables as we are, or faster, so that we reduce those emissions. This is a clear benefit, right? We're all benefiting from the carbon reductions that are occurring through solar. Then there's a cost, an externality cost, that comes through property value declines. And that is being felt by nearby property owners, okay, who again are outside of the decision being made. How do these externalities compare? How do the benefits of carbon reductions compare to the loss in property value? Well, we can put a value, a dollar value, on the carbon emissions reductions. Okay, so we estimated, given all of those solar facilities in Massachusetts and Rhode Island, that 495,000 megatons of CO2 are abated annually, combined for all of those solar arrays. If we think about a 30-year lifespan for the solar arrays, we're going to multiply that CO2 abatement by 30. Then we're going to multiply by the social cost of carbon. This is a number that the Environmental Protection Agency came up with through a lot of research, and it represents the damage that 1 ton of carbon does. When we multiply these together, we get $771 million of benefits through carbon reductions. How does this compare to cost? Or, yeah, the cost borne by property owners. So we counted 289,000 unique properties within a mile, right? Using GIS, not all of these were in our transaction sample, but we were able to count these properties exist even if they don't transact during our time window. So 289,000 properties worth an average of $338,000. If there's a 1.7% decline, this is a $1.66 billion loss in value. Comparing that to the benefits, we see that the housing value loss exceeds carbon reductions by more than a factor of 2. And so in this case, just in terms of externalities, right? We don't know about the profits that are being generated with the market, right? With the developers and landowners. We don't know about those profits. And so for a full benefit cost analysis, we would need to know those. But just in terms of externalities, we are seeing this loss in property value greatly exceeding the value of the carbon reduction. So that is, a little depressing. What will improve that benefit cost result? Well, there are some steps we can take, right? First off, siting solar in areas with few nearby houses, right? The fewer properties that are nearby, the better that ratio gets. Not siting solar on farm and forest land in urban and suburban areas, right? We saw these are the types of sites that are driving the biggest negative impacts on property values. And so if we move development away from those types of plots, that's going to greatly improve the benefit cost results. And so my thinking is that incentives or penalties can be enacted to steer development towards sites that account for people's preferences, right? And that's really the broad goal of this larger project, this larger grant, is to estimate people's preferences and then allow policymakers to create incentives or something of that kind that takes into account people's values for the area around them, the area. All right, so to conclude, the results are inconsistent with the null hypothesis, and we reject it, meaning that solar negatively impacts nearby property values. This is what I just said. The goal of the larger project is to estimate people's preferences for a location, for the location and attributes of solar arrays, and then argue that people's preferences should be accounted for in siting decisions, right? So currently the siting decisions are made by those market actors. And maybe the siting decision would be different if we incorporated people's preferences. Okay. That's it for me. I made pretty good time. And I would love to hear some questions.
All right, well, we have them. Let's see. I'm going to start with this one from Al. In your land use analysis, he didn't see any residential designations. Was that included somewhere?
So in the prior land use, right, it wouldn't, if it was already developed as residential, it couldn't then be developed into solar, right? You need large tracts of land.
Okay, perhaps. So let me follow that up with this rezoning question. How can rural properties that now find themselves abutting a newly rezoned parcel that was stripped of all vegetation not be impacted by commercial scale solar development? I'm wondering if that first question was in the spirit of rezoning that's happening.
Yeah.
And Al, you could clarify that if you don't mind in the Q&A box. Corey, any comments on that? We have other questions we could go to also.
I didn't quite understand it, but I think it might, issues about rezoning is a little bit beyond the scope of this talk and maybe my expertise. But maybe I just didn't understand the question.
Yeah,
Let's
no,
go to a
Al
new one.
said he's focused on the rezoning issue. So that's outside the scope of this project, Alfred, but we may be able to connect you with folks who could speak to that. We'll keep going. So the first question we received was, when considering prior use of land, did you include where the prior use is natural forest or otherwise unused but a natural condition like a meadow?
Yes. I mean, I believe, if I understand correctly, I believe we did, and that type of meadow, natural forest, that would be classified as a greenfield site.
Okay, good. What about, here's another question. These are great questions, folks. What about the loss of natural resources? There's clearly a cost there, especially in a rural community that values that element. I think we'd agree. I think the question's getting into and this may have come in before you provided the carbon cost estimate. So do you want to say anything else to this?
Well, I would say that what we're focused on here is property values, and that is one way to estimate people's preferences, but it's not a complete accounting, right? I might have strong preferences about how solar is developed in a town 10 miles from me. That's not going to show up in a property value study, but I still care about it. And so this is really about measuring proximity and the negative externalities that come with proximity to a solar array. It doesn't capture everything.
Great. So here's a question similar to or in the same vein as the previous question. With regard to the value of carbon emissions, did you account for the loss of CO2 absorbing forest land that has been clear cut for some of these projects?
Yeah, great question. We did not. That's a level of detail that we probably could have added that to the back of the envelope. Frankly, given the results, that would only make the benefit cost comparison come out worse, right? The costs would be even higher than the benefits, including the loss of carbon from deforestation. So the ratio was already so skewed that we thought it was good enough to leave it with that headline. But yes, deforestation would certainly come into that externality accounting.
That'll be the next study, right, Corey? So let's see. In West Greenwich, we have 5 major solar facilities totaling 135 megawatts on 660 acres within 1 mile of each other. Would this have a greater impact? And Kelly, we might need you to clarify greater impact, but Corey, does that make sense, that question?
Well, I think it makes sense. Let me try and answer it. One thing that what we don't look at is cumulative impacts. We actually specifically study solar sites that are a little bit isolated. And so we exclude from our study all sites that are within 1 mile of another solar array. The reason being is it just gets harder to estimate a clean treatment effect. And so that's why we did it for statistical reasons. But it is an open question of, if there are multiple arrays, is there an additive effect? Does that effect become larger? And that's a great question. It's very difficult to answer statistically, but it's a great next question.
She did clarify that she was asking about, yeah, effects on surrounding properties. So let's see, these are great. So Robert says, could the penalty or incentive be as simple as reducing the assessed property value of everyone within a mile by 1.7%, and then adding the lost value to the value of the solar site to make the tax impact null?
I'd have to think about that more. I like the creative thinking, but it's not just, a change in the tax, how much you're paying in property taxes. That's really, it's equity as well. So I like the idea that's transferring tax burden. I think it's a very interesting idea, but I'd want to think about it more.
You get a gold star for that one, Robert. We have we had a couple questions about whether or not the property values were evaluated if an array was in visual sight versus obstructed by forest or some type of vegetative buffer or setback. Can you talk a little bit about that?
That's a really good question, and the answer, unfortunately, is no. So this was almost, a very high level analysis that included 289, or I forget the exact number, 289 solar arrays across these two states. And we couldn't get that level of detail for each site. And so that is omitted. When we talk about an average effect, right? So the average effect is this 1.7%. There very well could be additional heterogeneity caused by vegetative buffers, caused by setback. I would love to be able to include that, but we just don't have the data, and it was not feasible to manually collect it from all of those sites. Now, what I would say is that next, right, our next study, which is in process, we have been distributing surveys by mail. We spent a lot of time sending out mail surveys. And the goal of that project, it's a survey, not a property value study, but is to get at some of these questions, the finer detail of, like, if a solar array is going to be sited here, what's the best way to do it? What are people's preferences for things like setback, vegetative buffer, visibility, size, and also land use? And so we're going to get at those types of questions, hopefully, with the next study. This one was broad brush, aggregate, macro, but it's really I think there's a lot of power in having 420,000 observations and 289 solar arrays. That comes with a lot of benefit, but at the expense of some of these details.
Great. Yeah, there's another question, which I believe you answered. Have you taken into account situations where there are multiple solar arrays in the immediate area within 5 miles or so? I think that's going to become more and more relevant as these continue to pop up. Research, what is the word I'm looking for? Is it a thing to just multiply your result by by however many arrays there are within an area?
No, I don't think that would be appropriate. I think it would be, it's sort of a new, the next research question is to look at cumulative impacts. If you have 2 solar arrays within a mile, how does that influence? How about 3 solar arrays, 4 solar arrays? That would be a lot. We do look at heterogeneity by size of the array, which is a different question, but maybe pertinent. And we find no differences by size. We don't, so smallest is 1 megawatt up to, now I forget the exact range, above 5 megawatts in the data. And we don't see any differences across the different sizes in terms of property value impact. things. Maybe that speaks a little bit to cumulative, but it might not.
Great. A couple more fantastic questions here. Do you think it would be worthwhile to perform a similar study concentrated only on Rhode Island, since we now have so many more solar installations within our borders, to see if the results you found for Massachusetts and Rhode Island still hold true?
I think it is a good idea. While we've had a lot more solar developments in recent years, what we really need is a lot of post-construction housing transactions. And so I think it would be great, say in 1 year, 2 years down the line, to do this study. And then I think there might be enough data in purely Rhode Island to assess this question. Now our data is quite recent through August 2019. And in the current data set, we do not have enough data to do just Rhode Island. So we're almost there, but maybe another year would be wise.
And a funder. And so Kelly's asking, and there were a couple other questions that I answered with a citation, but she's asking if you said that your research is first in this area to assess property values. And just so you know, Corey, a couple people have asked about other studies you've done on this topic. And so I did give them the Windy City paper citation. And if you just want to comment a little bit on your prior work and about this study in particular on solar.
Sure. So yes, this is the first property value study of solar arrays that we're aware of, which is exciting to be first. We've submitted it to a journal for publication. We hope that gives it a better chance. I have done fairly extensive other work using property value models. So as Kate mentioned, in 2013, I completed or as part of a group that completed a project funded by Office of Energy Resources on wind turbines, onshore wind turbines in Rhode Island. And then recently in 2018, the years kind of run together at some point. In 2018, I received funding from Sea Grant to look at offshore turbines, and I did a study of the Block Island wind farm. That was based on tourist experience. So it wasn't property values, but we used Airbnb data and looked at Airbnb rentals and how prices changed, how the availability, how nights reserved changed in response to Block Island wind. Other things I've looked at are brownfields in the state of Rhode Island, air quality, open space, conservation. That's another nationwide study. So I've done quite a bit of work with property values, and some of it, quite a bit of it's been Rhode Island focused, which is exciting.
I just did a quick search of the Block Island wind farm project, and there is some media coverage if folks want to just do a quick search. There was an article, if I can figure out how to post it here so that everyone sees it, I will, but that's a great question. We have just a couple more. We're at 8 o'clock, but we'll do a couple more here. So Ryan is asking that on the topic of Rhode Island, did the fact that state regulations require towns to tax solar at $5,000 per megawatt play a role in your analysis, maybe the externality part?
That's a good question, and I don't think it had an impact. Because we're studying localized disamenities, right? How these properties that are within 1 mile versus a bit further away are influenced. Tax payments to the town should, be evenly, if those benefit households, presumably they do, it should be evenly distributed between the treatment and control group. And so I don't think, I certainly don't know all the details on on that rule. But my sense is it would not have an impact on our estimates.
Okay. Sorry about the pup. Just two more. Tom says of the property studies, there a breakdown between rural and non-rural properties.
Of this study, I mean, yeah, so we presented results comparing rural to non-rural for solar arrays. And what we found is that the results, the negative results, are really being driven by those non-rural areas.
Okay, and we will end on this one in the spirit of how contentious this issue can be. David would like to know, is it appropriate to cite your results in a court case that's pending now in Rhode Island?
Ooh. I will say that these results, as I said, hopefully they will be posted on the Cooperative Extension website tomorrow. I have requested the IT person to post our report. Hopefully that's done tomorrow. I will bug him if it's not. Then it's up to you. You know, it'll be a publicly available resource at that point, and you can do with that what you will.
Well, thank you very much. Thanks everybody for your really thoughtful and engaging questions. Thank you, Dr. Lang and Vasu, who's here listening in. This is really exciting work. And I guess my last question for you both is, what's next? What should people expect? I will say that we do have a website for this project. If you, for lack of my ability to post something that everyone can see, if you Google solar siting conflicts URI, it'll come up. And that is really going to be a resource, a place where we post resources from this project and also related resources. So we direct your attention to that. There's about a year and a half left of this project. And then, Corey, anything to add about folks who are interested in the survey or connecting to us to find out what else we're going to do?
Absolutely. Yeah, so I want to say two things. One, I did allude to the survey that is currently underway. It's hard to say when we'll be ready to present results. 3-4 months might be realistic. It might also be a little optimistic. But sometime in the future, you can expect another webinar, or maybe even in person, but probably webinar, presenting those results and talking, more about the details, the fine scale details of some of the solar siting. The other thing is, there were some questions I couldn't answer or didn't quite understand about zoning, rezoning, or ideas about property tax adjustments. I find these questions really interesting. And I'd love to engage more. Like, if you want to have a conversation about what your town is doing, some ideas for what could be done, I'm happy to. I may not be an expert in that, but I'd be happy to listen and give you some feedback and think about how this research could apply to what you're thinking.
So folks can contact you. We're talking about search engines a lot tonight, but clang@uri.edu, right?
That's correct.
Okay. So we love getting email at URI, but seriously, we're here to serve you. And folks you can contact me. My email is kate@uri.edu if you have additional questions or comments, and I will make sure that Dr. Lang and Vasu get them. We're committed to continuing the conversation. And so thank you again for all of you who joined us. And we have another webinar next week, Tuesday at 7. So check it out. Thank you.